So far we've had a look at, with these diagrams, we've examined the free body diagram, which allowed us to do the calculations to get the basic numbers out. That is the reactions on the right vertical and the left vertical. From there we started to calculate out the shear force diagram, and again the formula that we were using was nominating a direction as being positive, and the sum of all shear forces must equal 0 for equilibrium. These we could actually plot straight away, and there was no problem with that. The final diagram we're going to look at is the bending moment. And again, with the shear force, first thing we're going to do is set a positive direction so we can then start calculating the moments. And the formula is the sum of all moments or bending moments must equal 0 for equilibrium. What we're looking at in this case is finding these plot points. I'll just do that in blue so we can see it. Finding these plot points. Once we do that, life gets a lot easier. We can just plot the points and work our graph that way. The other thing to look for with these here is the way that they're drawn. This first part is an arc, and that arc is representative of the universal distributed load that we see in our free body diagram. The next is a straight line to a point load, and in this case here our point load is the 554 kilonewtons. Straight across to our next point, and then from there we've got another arc coming through, which again represents our free body diagram there. Once we've got the points, it's easy to map out and easy to understand. As long as we understand it's straight lines to get the directions, and then the arcs representing the universal distributed load. So let's have a look at our calculation. Here you can see with the free body diagram, I've done one other thing here. I've actually labelled each of the sections where something important is happening, as that's where we'll be taking the moments from. So if we take the moments around A, understanding that for all of our formulas, we're actually going to be using, here's our orientation, sum of all moments, bending moments must equal 0. So around A, so bending moment at A equals 0. Why 0? Well, I'm taking the moment around A, and if that force is directly on A, there's no calculation. It can't go in any direction, so it equals 0. So here, on the next one, bending moment at B would equal force 1038.05 multiplied by the distance of 4, which comes out as being 4,152. So here, coming back to our chart, right, we've got a 0 end here, 0 end here. I'm going to come in the 4 metre mark and then go up in my scale to 1452, and then I can start to draw my arc in. And that's that first part of that drawing. Bending moment at C equals, here's my first one. I've got my positive 1038.5 by, excuse me, 8. And then I'm going to have minus 214 by 4, which will equal 5792. Now again, remembering this is still universal distributed load, so again here, I'm now coming in another 4 meters, going up to my scale, and that's that second part of that arc. So there's my whole universal distributed load drawn in. Bending moment at D equals plus, so you can see here, it's force by distance each time. 1038.5 by 4, 8, 12 minus bracket 214 by excuse me 8 which I'm taking it around D, so I can't calculate the 554 in at the moment. So that then equals 9944. So here I'm going up still a little. I'm going up directly because it's a straight line now to 9944. I'm hoping that you're starting to see the pattern here at the moment. So I've got bending moment around E plus 1038.5 by 16 bracket minus 214 by 12 minus bracket 554 by 4, which comes down to 10642. Bending moment at F equals plus 1038.5 by that's 16 and 14 by 30 minus 214 by sorry, lost train of thought there. 4, 8, 12, 26 minus bracket 554 by 18, which comes back to 13004. And remembering for this last point, we need to be coming back to the 0. So again here, it's the start. I'm now coming in that next distance, coming up to here. I've got my next distance here for my universal distributed load. And I've got this nice little arc forming and then dropping back down to the 0. So you can see here, by doing the calculations, I could find each of these points on the graph, which allowed me to draw that nice little arc that represents the bending moment diagram.